Well, hi, good morning, and thank you so much for joining me in my shop. So I'm going to do another day with this radio, and it's going to be another day of just kind of poking around and the like. So I'm just waiting for some lights to come on. Either I realize something about the radio or whatever. So I'm waiting for that breakthrough to come, and I don't think it's coming today. But one of you commented about my use of deoxit. So we're going to talk about that just a little bit. And I'm not an expert in this stuff at all, and my opinion means nothing. So this is I'm just going to show you some stuff, and you do with it what you want. So I avoided buying this stuff for years and years and years because it's expensive. But finally I thought, well, look at what I'm doing. I better buy some of this. This I understand to be the king of cleaners. I'm not saying I believe that, but that's kind of the reputation it has. Deoxit D5. I think there's a whole series of stuff, the D series. And what is this stuff? It lists it right here. It's a proprietary material called D series D100L. What's that? Odorless mineral spirits and diffuflorine or something like that. I don't know, some kind of, if on skin. Wash with soap and water. So anyway, when I'm not using this, which I don't like to use, it's expensive, I use the cheap stuff, WD-40, and I think this freaks people out who are really into the radio repair. The thinking is this fluid, and now I've been told via one of you viewers that this stuff will do the same thing, soaks into the wafers, that wafer material in the wafer switches, and can soften them, swell them, disturb them, or whatever. Can't say I've ever seen it. Can't say I've ever run into a situation where I went, oh wow, somebody used WD-40 and wrecked this. I've never seen it happen. So I don't really know what the best thing is, but this is cheap. Everybody has it. This is expensive. I look at the name on it. Deoxit. Makes you think it's going to remove oxidation. But what kind of fluid is it that removes oxidation without without being an acid or something that's going to do worse damage? So I don't know. But look, these aren't the only two chemicals I've got in my shop here. I've got a few more, and we're just going to look through them quickly. So here's some stuff you would buy. Non-drift TV tuner cleaner and lubricant. So this is like a WD-40 sort of thing. WD-40 is basically a volatile liquid with some oil in it, and they've been very selective on those things, and that's what makes their product so magical, I guess. WD stands for water displacement. Okay, so I got this one here. What is this stuff? It's probably alcohol. Safe for use on plastic parts and components used in tuners. Easy to apply, fast drying. Leaves tuner contacts clean with a fine lubricating film that is required for all color TV tuners. Color TV tuners need this. Magnasonic, Canada. Doesn't it actually say contents under pressure? What is in it? Come on, you don't have to tell us somewhere. Maybe not. Maybe they can keep it a secret here. Well, it's a secret material, but I think it's alcohol. Kettle cleaner. Yeah, that's right. I'm not saying I'm ever going to use this in my shop. Removes scale safely and easily. So, and what is this stuff? Contains formic acid. If it's splashed on your eyes or in your skin, flush away. Okay, so I don't think we want to put acid into any of these radios. So, Motomaster is a brand name from Canadian Tire here in Canada, and electrical contact cleaner, and it's aimed for car contacts, that kind of stuff. This stuff, when I use this kind of stuff, I find the switch is very hard to operate afterwards because it's cleaned and dried everything off to the point where it's kind of grinding. Whereas these other products leave a little bit of lubrication behind, which I think is very helpful. Do not smoke. Do not puncture. Do not burn. Do not swallow. Do not get in eyes. Do not breathe fumes. Use only in a well-ventilated area. First aid treatment contains heptane, that's the propellant gas, propane, propellant gas, isopropanol, so it's alcohol. That's it. If swallowed, cause control center or a doctor immediately. Do not induce vomiting. Well, it's got something more in it than just alcohol. Okay, there's various kinds of alcohols. Here's another ton of power. I think I've showed this one before on my ton of power. 5 seconds. It's 5 seconds. Wow, look at this one. Crown rust inhibitor. Now, this is an interesting material. Industrial strength crown rust inhibitor for industrial, marine, aviation, farm equipment, automotive, and fixing old radios. Made in Canada. Shake well. Contents under pressure. Do not place in hot water near rads, stoves, other sources. Blah, blah, blah. First aid. If swallowed, call physician. Contains petroleum distillate. They're not going to tell you too much of what's in here. Rust inhibitor. So, you know, oil is a rust inhibitor. Many rust treatments for cars now. It's just oil. Maybe a particular kind of hydrogen peroxide. We all know about that stuff. Not sure it has any place in here. Look at this. Trichloroethane. A little bit in there. Then this is the kind of chemical that they found out later was dangerous, isn't it? You know, you have it in your school, then all of a sudden, oh, we got to get rid of that. It's killing everybody or something like that. Wow. Okay, here, Neutral contact and control cleaner with lubricant. Cleans and lubricates. Selector switches. So this is selector switches. So I mean, that's exactly what's in this radio here. What's in here? Material safety data sheet is available. So this is a fairly new product here. Like it's not like 30 years old like that other stuff I'm showing you. Lung irritant, skin irritant, avoid contact with skin, no smoking, case of fire, use a CO2 dry chemical under well-ventilated conditions. What is it? If splashed in eyes or skin, flush thoroughly, remove victim from gas, call poison center, obtain medical help immediately. Here we are. Chemical contents. It's the 1112 tetrafluoroethane, petroleum seal oil. What? Seals gave up their lives for this stuff? Seal oil. Hexane isomers. That sounds dangerous to me, but this would probably be ideal for doing contact cleaning in here. Like it's taped closed. No one wants to use it. It's full. How about this guy? Woo! Say that quickly. Removes all types of organic flux. And what is in here? Fast cleaning action. Removes all types. Self-cleaning. No brushing required. Excellent for spot flux removal. Non-flammable. Safe for most circuitry materials. The ultimate in organic flux removing sprays. Penetrating solvents remove even the toughest deposits without harm to the delicate circuitry. Flux off in aerosol form provides a constant fresh supply of solvent, preventing recontamination, making it more desirable than bath defluxing. So you're gonna, it's just like the hurricane that hit Florida. It comes in and just keeps pushing stuff further away. Contents under pressure. Don't stick it on your stove. Keep it away from children. Contains 97% active ingredients. Oh my God, what is this? Azeotrope of trichloroethylrothafane and methylene chloride. Propellant, 3% carbon dioxide. Yeah, well, so full, but again, I'm not going to spray that on this thing. My last weird chemical, methyl hydrate. Why would I even? So I got this from my father-in-law when he passed away. He had a bunch of this kind of stuff, and I've just had it ever since. Sheffield methyl hydrate, original solvent for shellac. Cleans shellac brushes. So that's what this is, shellac cleaner. There we are. So there's all my options of when I'm going to clean something. I have all these chemicals I can select from, and I got more stuff up there. I won't bother showing you. But really, my favorite buddy is WD-40, and I have been using this deoxit stuff here and there. None of this other stuff. Well, once in a while, actually, I do use this stuff once in a while. Okay, there we are. So there's the story on all kinds of chemicals, and and you can spray on things. Some of this stuff, the cleaning benefit, and they even hint at it, is not so much the chemical itself, but the flushing action. You put enough in to flush away the stuff, or get enough in there to liquefy things, so they'll so you can swoosh them around and get a better response from whatever it is, the switch or maybe the volume control. So I think this thing, there's a series of these. There's one for sliders. There's one. Come on, really? You got to be kidding me. Really? It's the same stuff over and over, isn't it? Really? Oh, I got another can of cleaner here. Contact head cleaner. Do not smoke. Never smoke, actually. First aid treatment. What is it? If on clothes, remove clothes. Yikes! What is this stuff? So here it is. Contents, not in English. Where's it in English? I can read it anyway. Contains or content. Isopropanol, isobutane, and propane. So, well, isopropanol. That's just alcohol, isn't it? Remove your clothes? Hey, this would be great at parties. Oh, look, I just spilled that on you. Sorry, can you take your clothes off now? Okay. Wouldn't really recommend that. Okay, enough goofing around. Now it's time to get down to brass tacks here. Brass tacks, where did that come from? So when I take little breaks, I'm usually watching videos on YouTube. Hey, how about that? But I'm not watching technical videos normally. I'm watching kind of entertainment stuff. And I've been watching this guy from Australia, and he's Aussie something or other. Anyway, he puts these short videos on and then just makes these funny comments on them. I get quite a laugh out of it. So watching some of those, I ended up pouring coffee on myself. Yeah. So I've got different pants on here. Yes, I poured half my cup of coffee right on my lap. I jumped. Okay, enough of that. It's excitement everywhere. Excitement in the shop, excitement out of the shop, everywhere. And now I got to face this thing. I've been trying to avoid it all this time. I got no plan. I'm standing here with no plan to go forward, and that's no good. I've got to come up with some idea. Well, one of the things that's going through my head is to try to trace the signal step by step, right from the antenna, right into, I don't know, the first component or something. I'm not convinced there's a signal getting anywhere from the antenna into this radio. Right? It just doesn't seem to show up anywhere, really. Oh, I'm off to a bad start here. I'm off to a very bad start. Okay. If I want to find the first active device, I'm just looking around here. I mean, right away your eye can spot this transistor here. It says Q1 RF amp. So if you follow the base back, you find, the line's kind of disappeared here, but it goes here. And goodness knows what's going on down here. That's not where I thought it went. But in any case, this has to be the first amplifier. Somehow the antenna signal going through these tuned circuits is somehow getting here. Maybe I'm just not looking at it right. I don't know. Through here, I guess through here somehow. I think what I should try to do is feed a signal in. Now, the problem here is a lot like my signal tracing equipment. It works on the AM radio band. And on IF frequencies. Not matching the ones in this radio. The broadcast band frequency in this radio, if you try to pick it up, is complicated because they convert it up to, here it is right here, 26 megahertz. They convert it. I'm trying to avoid that part of the circuitry because it's just another complication, another area for trouble. So I'm staying on the higher bands which do not utilize this 26 megahertz conversion step. So coming in here, going through these switches, selecting this what set of coils you want, and then we're then coming out, and I think we're going through here, and then over through another selection of various coils and capacitors, and then onwards. Yeah, I got to find where Q1 is, and I got to somehow get on a test point here, and bum, 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 bum. That's about it. What kind of signal can I put in? It has all these filters here, so I've got to put in something. I'd have to do this at 4 megahertz. 4 megahertz. I use my scope to look for the signal. I think that's probably what I'm going to have to do. Okay, I got a plan. I got a plan of action here. Okay, I don't have the set on. It's not switched on or anything. I have an input, a 7,000 megahertz signal coming into the antenna here, and the first transistor is located deep down in here. So first I'm going to contact where the signal is coming into the radio to see the size, calibrate the size, so to speak. So there you have some trouble seeing it here. You can see it's about this big. Yeah, you can see it there. Looks a little funny on the camera. Now we'll go to the first transistor, again with the set not operating, and just look for the signal to be there of a similar scale. For crying out loud. Oh, and there it is. Exactly the same scale. Let's just change bands for fun. I think there's filtering involved here. You see it's much lower now. So I think that's the front end filtering operating. Okay, so that shows the signal makes it to the first transistor. I don't know if I want to go transistor by transistor. Let's look at the schematic here. Okay, the next transistor in the chain I believe is Q3, first conversion mixer. And what I'm thinking is the signal that I saw arriving at the other transistor should appear here on the base. Anyway, conversion mixer. What's it mixing in with? You know, I'm used to a tube with multiple grids. This only got one base connection, so I guess the signals are coming in both on this. I don't know. So I've looked at the transistor, I've located it, I can see it. I can also see this resistor, so I can identify this terminal. And really the terminals I'd be interested in would be the base coming in and the collector or emitter, whatever this is, going out. And so I'm going to try to read those two, and we'll turn the set on. We'll see some gain from the first transistor, or at least a signal will come through, and we'll see it. So I'll look for it with the set off. I'll pick either one of these two leads because I don't know which is which. Well, one of them has a 390. Well, one of them has a shielded cable. Come on, mouse. What's with you here? It has a shielded cable on it. Maybe I can spot that. Okay, let's take a look. Okay, the transistor is right at the top of the screen there. See, right up in here where this is it. Here, this is the socket for. You see, right almost center is a resistor, brown, black, red, which is a 1,000 ohm resistor going to a ground terminal. I can see the interesting ground strap that they're using in this radio. This copper band here, which is running through the radio. So that's how I've been able to spot this on the schematic. I recognize the 1,000 ohm resistor going to ground there. So the terminal that resistor is on, which I think is the one we can't see, is not the one I want to get at. The one I want to get at either has that capacitor there, or the other one with the resistor hanging off of it. So I'm going to try to... The set is not on yet, so I'm still doing this I'm going to try to hook up my scope here. I'm going to get my hand in down there. I'm not sure I can do this with a camera. I think I got to do it with my own eyes here. Okay, there we go. I'll just clip the ground here. We're on the times 10 setting. Okay, I have a very strong signal coming into the radio. I'm going to cut it back because it's kind of crazy strong. Okay, and I'm going to check the calibration here. Modulated for no good reason. Okay, now we're going to power up the radio. And well, first there's nothing on the scope, so nothing there as it is. So, but I cut the strength back, didn't I? I'm just going to lean over and turn it back up here. Yeah, there's still nothing on the scope, so nothing's getting through to this point without the set operating. Okay, so I'm going to pull this off. I'm going to turn on my new silent power supply. I'm going to turn the power supply on to the power supply. Yeah, that helps. There we go. Okay, I'm going to turn the radio on, and what happens here? So the DC voltage is throwing the scope right off. So we do see a little bit there. It's hard for you to see where you are. I have this set as sensitive as it'll go. Remember before the signal was this big? Now it's only that big. That doesn't mean things aren't working. What kinds of things could be involved? We spin this tuning knob. Anything happen? Nothing. Nothing happens. Nothing happens. And what if I do the this is the pre-selector control? This one might do something here. Ooh, was it ever? Some weird stuff going on there. I'm going to put a better camera on the scope. Okay, so I'm not ready to record, but there's sound coming out of the speaker. Oh my gosh, there's sound coming out of the speaker now. It just suddenly started. I just flipped on the camera. What's happening? Is it starting to work? What are the chances? No, it's more likely something else is breaking down. No heavy current being drawn by it. But there's definitely sound coming out of there. Is it because I have the scope hooked up? Oh, it's gone now. That was pretty interesting. That was very interesting. What happened? What happened there? Oh, it's trying. It's trying to come back. Okay, in the meantime, I should really tune the radio rate to 7 megahertz. Let's do that. The one of the catches with this radio is if the pre-selector is very sharp, apparently, if you don't have it on target. And that may be just... That's not the best sound at all. that's not a good sound, but that's the first thing I've heard out of this radio, though. Okay, getting back to what I'm doing. So 7,000. I don't want to do 7,000 because it's right on the change. We're going to do 7,250. Okay, I'm going to tune in. Oh, this is way off. Wrong band. Oh, listen to that. Look, did you see the light? Anybody see the light? The light, the radio went dead when the light came on. That's operating. This radio started operating. I just need to hook up an oscilloscope to it. Do you think this radio is really operating? Oh my gosh, I'm so excited now. Calm myself down. It's set for 7. And the big dial is 7, can't read it, 7250. Okay, let's swing this around and see what happens. It's a strong signal. Oh, too bad. So excited. Okay, so what do you think we're hearing? Could it be the oscilloscope connection is generating noise that's going into the radio? It's the first time the radio's had something to work on. I doubt that. I doubt that. What could be wrong in the way I have it set up? What about the volume? Oh my gosh. Well, okay, finding a few more things out. Dirty controls. But they're working. RF. No, this is AF. RF. Boy, that sounds like a radio. I gotta put the antenna on it. Don't give up. Wait a minute, should I tap it? Tap it, tap it. Where? Tapping. I've been so successful at doing this kind of thing to radios, I can't begin to tell you. The tapping thing. It had a pop when it started and stopped. So the pop indicates a component failure to me. Not necessarily though. You have a contact to break open the voltage builds, and when contact touches the voltage discharge, you get a pop. That's kind of weird. That's kind of weird how that's doing that. So I did put the cleaner on here as we were. Come on. Seems like maybe the contact's made, it takes about a fraction of a second for the sound to come through. So that makes it difficult to do this experimenting. Put the antenna on. Put an antenna on. Put an antenna on. Quick, man. As you can. Well, that didn't make any difference. Antenna's on. What am I hoping for? Well, you would think if I disconnect it, the hiss would go way down. Can it be the scope? You take the scope off this end here. Don't think it's the scope. Change the scope to ×1. Any difference in the signal. This could be coming from somewhere other than back here. What about this guy? Didn't this make... Actually, you can't see what I'm doing now, but I'm turning that same... Is it the antenna connection itself? No. It just seems like any flexing of the radio in certain areas, and I don't know, nothing consistent here. You can see what I'm doing. So So something like that usually indicates a ground connection is come loose somewhere. And I see there are ground connections made to screwed down rivets. There's no solder. So any one of those could be causing trouble. Oh boy. Oh boy, oh boy, oh boy. Yeah. So a lot of poking required here. So odd. I'm hardly moving anything here. It's just proximity. Wonky switch. Wow, and that was really, really touchy. Fully anywhere here. So when the sound goes out, the scope doesn't. The scope shows the same thing. The problem's got to be beyond here. Oh my gosh. You know what I think might be happening here? Let me turn this down a bit. Yeah, that's turning it down all right. It sounds to me like it's electronically going out and coming back. That's what it sounds like. Is the red light coming on every time I do that? It is. So the red light's coming on. So what's happening is I'm simply interfering with the synthesizer's ability to lock. It's probably on the edge of the lock, and I'm messing around here. I'm disturbing that. It's going out of lock, and the radio's going quiet. The good news is that's how you want the radio to perform. That's what it should be doing. What if we try some more bands? Well, I tried the broadcast band, and because there's stuff there, you know, with the way the sun is right now. Oh, last night my wife and I were outside for a long time looking at the Aurora in the sky. The whole sky was Aurora, but the weird thing is, you look up at it with your eyes, and it's kind of whitish. It looks like thin clouds. It doesn't really look like an Aurora. Occasionally, the sky would turn red. It was really. We were out there for a long time, so all kinds of stuff happened in the sky. But much of the time, it's just white. And then my wife took her nice iPhone. She's got an updated iPhone. I don't. This thing can take pictures where the shutter's open for a few seconds, and if you wobble around, it doesn't matter to the camera. The camera can handle it. Amazing. So she was taking timed exposure photographs, all done automatically. And when we look at the photographs, instead of seeing white, we're seeing the red and the green, and we're seeing all kinds of detail. I cannot see it with our eyes. So what we learned is, you go outside, you see something that looks like it might be Aurora, then get out your iPhone, your new iPhone, and shoot some photos of it, and look at the photos. Wow! And I'll have to put some on a YouTube video or something, because it was really fantastic last night. That's one of the best displays I've ever seen. Whole sky was lit. Oh, I got excited. Okay, so you see, the thing is just run along without any kind of misbehavior. I'm not poking away at it, so I'm sure that's all I was doing. You know, just. It's amazing, eh? Just touching the surface of this. I touched this one. All surprising to me. Okay, so we were going to try the broadcast band before I got all excited about remembering the Aurora last night. Okay, so we're gonna go first up in bands so I can stay away from that 26 megahertz converter. Stay away from that for now. So we're going to go up. Oh, going up to. Oh, look at that. The light is out. Radio's operating. Oh my gosh. I'm afraid to remove this. I think it's going to ruin everything. So don't remove it for now. Okay, we don't know what that tone is. Can I not? Why so much hiss? All those tones sound exactly the same. We're on 25 megahertz. That's crazy. I don't want to be up there. We want to be way, way down from there. So we're going to go down. The radio's behaving perfectly normal. When the light goes out, you hear the hiss. So where are we now? 22, 1, 20. Wow, it's working really good. Holy smokes. Well, it's not receiving anything yet. So we're on 20. That's still pretty high. I really want to be down. We really want to be way down from there. I'm on the 20 to 30 band, so we're not going to go anywhere. Let's go on the 10 to 20 band. It's working. And we're on 10. We want to go to, we want to go up around 11, 11.5. Okay. There's strong shortwave stations here normally. Yeah, I don't think it's working. What's that? Maybe this capacitor hasn't been working for a while. We're at the end of the run there. So we're up around 12 megahertz. I don't think I have the antenna turned on. Oh! Okay, I had to go turn the antenna on. Huh. Okay, let's see what happens. What's here? I think I hear something right now, but I imagine it. Oh! I'm floored. Okay. Sounds like it's in BFO mode. It is. Okay, so we're going to switch to AM mode.
¿Cuánto ha cambiado la sociedad cubana en los últimos 60 años e incluso en los últimos...
That's RF gain. Lots of audio. Tell me it's a combination of dirt in the controls, dirt in the switches. And that's all that was wrong with this. Is that really the case? Oh, I'm going to take off the oscilloscope here. It might get louder. I'm going to try to take it off. Okay, I've got to shut the set off for a second. Oh, watch this. It won't work. There. I'm too worried about shorting something out in there. Set back on. Come on, baby. Pretty weird start up there. But it worked. Oh my gosh. This is miraculous to me. A miracle has occurred right here. Let's see what we can do with the quality of the sound. A little more volume. RF gain. EGC. Off. On. What else could we do? Rejection tuning. So this is a notch filter. Oh wow, this is many turns here. Off. This is passband tuning for single sideband. Shouldn't be doing anything. Bandwidth. We're at 8. 6. Uh-oh. 2.5. Maybe I'm tuned off. Okay, we're going to go down to the broadcast band. Engage the 26 megahertz conversion. Okay, so I'm on the 1 point. I'm going to go to the 0 to 1.5. Now I want this up 0 to 1.5. So we could put this on 500. That would be a good place. 500. That's 500. And we're at the top of the band. I'm going to go down this dial. 80. This way. Anybody home? Doesn't sound like it, does it? Not sure what that's all about. Double checking that. I'm on the 0 to 1.5. That sounds like that's the 0 through the broadcast band. Oh, I never did this guy. This guy. So on the broadcast band, right now we're at, well, if I'm at 0, no, think about it. You're on 0.5, you're on 500 kilohertz plus. So this would be 600 kilohertz, so 590. So it should be a strong station right in here. So try this now. Doesn't seem to be doing anything. Okay, we'll go next band up. This is the 1.5 to 4, so it's basically above the broadcast band, but we might hear something up there. Once the phase lock light is out, but we don't hear anything. Well, yeah, we should hear something, shouldn't we? So we're at 3 megahertz. We want to be 2.5. What have I got this turned to? Three, 2.5, a lot of funny sounds. Okay, there we are. So what that shows you is the 26 megahertz conversion circuit is working also. Floor me totally. Okay, let's turn this back up a minute. It just sounds like AM radio, doesn't it? What station that was? There's another one. Lots of music I'd like to listen to there, but I'll get a copyright hit if I let it play. Good for about 8 seconds. Probably gone off the top of the, let's see, 160, 170. So we're at, where are we? So there's nothing on here to see. $1.5. How come it's quiet? How come it's gone quiet? I played with it too much. We were really going good there. What exactly was I doing that caused that? Okay, could just be volume. Yeah, that's all it was. Just the volume. Well, okay, I'm going to stop playing with the radio. That's it for today. That's fantastic. Wow. It's amazing. I'm really feeling no hope for this radio all the way through till the moment it started to work. Wow. Okay, lots of fun here. Maybe tomorrow what we'll do, I'll set this thing up so we can put it through its paces and see what it can receive and all that kind of stuff before doing anything more to it. Wow, I can't believe it. Huh. Happy day. Well, you have a good day, because I'm going to be pretty happy today. See ya.